Chash, load balancer service in Kubernetes. A load balancer service in Kubernetes is a service type that exposes applications running within a Kubernetes cluster to external clients via a cloud provider's load balancer. It automates the provisioning and configuration of the load balancer, enabling seamless access to services from outside the cluster. Key features of load balancer service. 1. Automatic load balancer creation. When a service of type load balancer is created, Kubernetes automatically provisions an external load balancer through the underlying cloud provider, e.g. AWS, GCP, Azure. Direct external access. The service is assigned an external IP address, allowing external clients to access the application directly. 3. Traffic distribution. The external load balancer routes traffic to the node port or cluster IP service within the cluster, distributing requests evenly across the backend pods. 4. Integration with node port and cluster EP. A load balancer service uses node port and cluster EP services under the hood to forward traffic to the appropriate pods. How load balancer works. 1. Service creation. When you create a service of type load balancer, Kubernetes interacts with the cloud provider's APIs to create a load balancer and associate it with the service. 2. Traffic routing. The external load balancer receives traffic on its public IP address and forwards it to the node port or cluster IP service. From there, Kubernetes routes the traffic to the backend pods based on the service's label selectors. 3. Health checks. The cloud load balancer performs health checks on the nodes or backend pods to ensure traffic is only routed to healthy endpoints. 4. Dynamic updates. As pods scale up or down, the load balancer service dynamically updates its backend configuration to include or exclude the appropriate pods. Benefits of load balancer service. 1. Seamless integration. Automatically provisions and configures external load balancers with minimal manual effort. 2. High availability. Distributes traffic across multiple nodes and pods, ensuring resilience and availability. 3. Simplified external access. Provides a single point of access for external clients via an assigned public IP address. Limitations of load balancer service. 1. Cloud provider dependency. Requires a cloud environment that supports load balancer provisioning, e.g. AWS, Azure, GCP. 2. Cost. Provisioning a cloud-based load balancer incurs additional costs, which may not be suitable for smaller-scale setups. 3. Scalability. Not ideal for very complex traffic management use cases compared to ingress controllers. Use cases for load balancer service. 1. Public-facing applications. Ideal for exposing public-facing services like websites or APIs. 2. Single point of access. Provides a straightforward way to route external traffic to internal cluster services. 3. Quick external access. Useful for quickly exposing applications during the early stages of development or testing. Summary. The load balancer service in Kubernetes is an efficient solution for exposing applications to external clients via a cloud provider's load balancer. It simplifies service access by automating load balancer provisioning and configuration while enabling traffic distribution and high availability. However, it is most suitable for cloud environments and may not be ideal for more complex or cost-sensitive deployments.